And the next speaker is Dr. Hitoshi Hirose, Japan Aerospace Exploration Agency, Japan. Title of the talk is A Correction Method for Improving GS Map Precipitation Overestimation Bias in the Tropics. Over to you, Dr. Hirose.
Okay, can you hear my voice?
Yeah, we can hear your voice and see your slides as well. Yeah.
Okay, let's start. Okay, thank you for everyone. Today, I'll talk about one of the GSMAP improvements that was made in the measure algorithm update to version 8. First, a brief description of the purpose of my presentation. The GSMAP uses frequent observation of the cloud by geostationary meteorological satellites to interpolate gaps in the Pacific microsatellite observation network. Okay. But it has been reported that there is a discrepancy in the precipitation estimation accuracy of the GSMAP between two areas observed by Pacific microwave and GEO. In this presentation, I'll explain a historical matching method that was introduced into the GSMAP algorithm version 8 for reducing the accuracy difference between these two regions. Here is an example of the GSMAP accuracy difference between Pacific microwave and geo-observing areas. This figure is an hourly rain rate snapshot of the GSMAP algorithm version 7. The black shaded area indicates rain rate observed by Pacific microwave direct observation. The gray shaded area indicates rain rate complemented by using geo-IR observations. The interpolation product using geo-IR tends to overestimate rain rates compared to Pacific microwave observations. This has causes gaps in the rain rate at the boundary between the Pacific microwave and the geo-IR observing areas. The purpose of this study is to reduce this accuracy difference between these two areas. Next, this schematic diagram describes the standard algorithm flow of the GSMAP MBK. The GSMAP preferentially uses direct rain observation by the Pacific microwave satellites whenever it is available. But if the Pacific microwave observation is not available, the GSMAP calculates the moving vector of precipitating cloud observed by the Pacific microwave in the past by using geo-IR frequent observations, geo-IR observation. This cloud moving vector is used to estimate the destination of precipitation cloud observed by Pacific microwave sensors from time with t to t+1. Precipitation cloud is moved. In addition, the GSMAP uses the Kalman filter to correct the time varying precipitation according to cloud top temperature. So the lower left figure shows the correspondence between rain rate and the geo-IR versus temperature of the cloud top. The correction value for rain rate is obtained from the fitting function in this figure. This combined use of Pacific microwave and geo-IR observation to interpolate precipitation is called the combined algorithm. This algorithm product. As shown in the previous slide, the precipitation interpolation of the combined algorithm is not perfect, resulting in the accuracy difference from direct Pacific microwave observations. So, to reduce the accuracy difference between the combined and Pacific microwave algorithm, the histogram matching method shown at the bottom was introduced. This method directly corrects the rain rate histogram of the combined product. So, yes, using the Pacific microwave observation as truth. Note that the histogram matching is only applied to the combined product, not to the Pacific microwave directed observation. Next, I'll discuss why rain overestimation occurs in the GSMAP geo-IR observing areas through a case study analysis in the tropics. The center and right figure shows the rain rate snapshot of the GSMAP, but in the right figure, all regions are estimated by the combined interpolation product without using Pacific microwave observation. A large rain rate difference exists in the black shaded area in the center and the right figures. The left figure shows time variation of the geo-IR brightness temperature Blue color means cold upper clouds. Deep convective clouds were swept away by upper east troposphere easterly winds, and we could see the upper clouds spreading over a wide area. Here, the GSMAP calculates the cloud moving vector by using zero IR observation, this one. So in this situation, the cloud moving vector is basically calculated in the westward direction because it is strongly affected by upper clouds over the large areas. But in contrast, the black shaded area in the center figure shows that most of the rain from the upper clouds observed in the Pacific is not so strong, this area. So under the strong vertical shear in the tropics, the GSMAP algorithm often misinterprets rain positions as moving to the west. But in fact, middle or lower level cloud with heavy rain didn't move to the west in this case. In addition, the GSMAP uses Kalman filter to correct the rain rate according to the cloud top temperature. At the destination of precipitating clouds, since the upper level cold clouds are spreading to westerly, it is thought that too strong rain rate was estimated over a wide area as shown in the right figure. This is the reason I think so. Next, here is an example of the improving the rain rate histogram of the combined product by using histogram matching method. Bottom figure shows histograms of the GSMAP rain rate. So in figure A, blue color indicates the passive micro observation, truth, and red color indicates the combined estimation. The combined product has less rain samples below 1.8 millimeter per hour compared to the passive micro observation. Conversely, the combined product has more rain samples above 1.8 millimeter per hour. So the green color in the figure B shows the result of the corrected combined product by using histogram matching, which is in good agreement with the passive micro observation. This green histogram is good agreement with the blue histogram, passive micro truth. So next, here is an example of the GSMAP improvement by using histogram matching method. Left and right figure show a rain rate snapshot before and after applying histogram matching, respectively. In the passive micro observing area shown in the black, the result didn't change. It can be seen that the rain rate in the zero IR observing area, gray shaded area shown in the gray, is significantly reduced by histogram matching, and the gap between passive micro and zero IR observing areas are greatly reduced. The histogram matching shows a marked improvement in the rain overestimation. Next, to statistically evaluate the result of improving estimation accuracy of the GSMAP, the zonal mean rain rate accumulated for a month were compared before and after applying histogram matching. Figure A and B show that the combined products shown as red line overestimate rain amount compared to passive micro observation, black line, both over the ocean and over the land. Very overestimation in the tropics. In contrast, the combined product after applying histogram matching, green lines, shows a significant improvement in the rain overestimation in the tropics. The green lines are in good agreement with the black lines of the passive micro results in the tropics. Next, the right figure shows the 1 month average rain rate difference between the combined estimation and the passive micro observation by 9 cloud types. Figure A shows the result before applying histogram matching, figure A, where positive value indicates rain overestimation of the combined product. It can be seen that very large overestimation were occurring in the deep convective and zero stratus among the upper cloud category. Figure B shows the result after applying histogram matching, and the rain overestimation for such upper clouds has been greatly reduced. On the contrary, the combined product tend to underestimate rain rate for middle or lower level clouds. The underestimation may be due to the fact that the GSMAP combined product tend to miss precipitation from the middle or lower level clouds compared to past micro observation. The histogram matching cannot compensate for missed precipitation. So this underestimation problem remains in the GSMAP algorithm version 8. Summary. In the algorithm version 7, GSMAP combined product tended to overestimate rain rate in the tropics compared to past micro observation. But in algorithm version 8, the rain rate histogram of combined product was modified correspond to that of the past micro observation by using histogram matching method. So the rain rate overestimation was greatly reduced after applying histogram matching, especially in the tropics. This histogram matching method and another smoothing method between the past microwave and the combined product was introduced in the GSMAP algorithm version 8. These two updates are expected to allow you to utilize more homogeneous GSMAP product. That's all. Thank you.
Any questions?
Yeah, sir. Dr. Hitoshi.
Hi.
You mentioned about there's a problem in the combined product, which is overestimating the rain in the tropics compared to the passive microwave product, right? So why is it so actually that this product is basically overestimating? What could be the reason behind it?
So, oh, sorry. Sorry, please. Okay.
Yeah, the question is why is it that the combined product overestimates the rainfall over the tropical regions as compared with the passive microwave product? What could be the possible reason behind it? Why it is so?
Yeah. So possible. Yeah. Probably, I think So permanent vertical wind shear exists in the tropics. Therefore, convective outbreak with heavy rainfall. This one. Often move to the opposite direction to the upper crust. This is often exists in the tropics. However, the cloud moving vector of GSMAP is influenced by wide splitting upper crust. So often cases the cloud moving vector move to west, but this vertical wind shear under this strong vertical wind shear, so convective outbreak is not move to the west. So
okay, okay, fine.
So,
I think in one of the slides where you showed the rain rate versus the brightness temperature over the ocean, right? Actually, there are differences that are observed in the correction or the bias. And also the rain rate scatter is quite high. If you see the figure, you can see that the scatter is quite high. One of the, I think in the slide number 2 or 3, at the beginning.
Okay, slide number 2 or 3.
I think it is number 2 or 3. Not this. Yes, this figure. Yeah, slide. Okay. This particular slide. If you say the brightness temperature and the rain rate,
yeah,
you can see the scatter that is happening actually at a higher rain rate actually. When you're going towards a higher rain rate.
Yeah, very higher rain rate. Yeah.
So what could be the possible reason why the scatter is becoming so higher actually? In this
this is a difficulty in the fitting only using single IR band. So this is the rain rate and the IR brightness temperature correspondence. But this fitting, you can see fitting is not easy. Perfect fitting is using single IR band. So this is a very high upper class situation. So Kalman filter correction is overfit. Okay, overestimate rate. Yeah, probably. Yeah, I think. Yeah.
Okay, so thank you, Dr. Hitoshi.
Thank you.
Dr. Venugopal, you can go ahead.
Dr. Hirose, can you hear me?
Yeah. Yes. Okay.
Could you go to slide 8, please?
Slide 8. Okay.
perhaps the answer is in what Dr. Bhaskaran asked. So why is, so yes, there is an overestimation in your combined product, but what is it about the core of the ITCZ that makes the combined product go completely crazy? It seems like your overestimation goes rather high. I mean, it almost seems like it's 20 to 30% from the numbers you have here. Unlike the other areas of the tropics, the core of the ITCZ around 7 north. Is that again the same as what you were referring to as the wind shear earlier?
Yeah. So I think
why the difference in
okay. Why different? The mid latitude, the tropics are very different. So one reason is in tropics, vertical wind size very strong vertical wind is always exists. But under next another reason is upper cloud. In the tropics, upper cloud is a very large area is covering the upper cloud. So this overestimation is almost all exists in the upper cloud category only. So so this is probably in the difference between middle latitude and tropics. I think this overestimation of rain is only exists in the upper cloud category, deep convective cirrostratus or.
Okay, all right. Thank you.
Thank you.
So if there are no further questions, let us thank all the speakers in this session. So now over to organizers.
Thank you for all the speakers for wonderful presentation, and we would like to thank Dr. D. Jagdish and Dr. M.V. Ramana for chairing the session.